All right, pre-cal 10, here we go. Video number 4, and we're going to move into irrational numbers. So these are those squares and cubes and fourth powers that aren't perfect. That's what I was alluding to in our last video. So here we go. If you have a perfect square, a perfect cube, perfect fourth root, you have a whole number answer. In the realm of a cube root or a fifth root, you'll see you could have an integer answer, which means a negative, but you'll look at that in grade 11. But let's just look at what happens if they're not perfect. So what do I mean by that? I mean, what about the square root of 15? Well, that's just the square root of 15. Or what about the square root of 24? Well, those numbers aren't perfect, but we can actually work with those. We can simplify those. And we can simplify them in the same way we would simplify by removing other factors. So let's have a look. So before we get to simplification, how about estimation? Well, what is the square root of 19? Well, think about the number 19 and then perfect squares around it. So perfect squares, well, I know 16 is a perfect square just a bit before 19, and I know 25 is a perfect square after 19. So it means that 16 is in between 19, which is in between 25. So if I square root all of those, I get the square root of 19 is in between 4 and 5. So you can already estimate the fact that 19 is a little bit more than 4. But then if you look at the fact that 16 to 25 is a difference of 9 numbers, and that 16 to 19 is a difference of 3 numbers, it means that 3 out of 9 of those numbers, which is 1/3, which is 0.333 repeating, is the amount that is in between 16 and 19. So you can just say with relative confidence that the square root of 19 is 4.33, let's say. And if you were to plug that into a calculator, the square root of 19 comes out to exactly 4.36. So we're close enough. So that is how you estimate. It doesn't have to be perfect. Realistically, it's between what two whole numbers does it fall. That's generally good enough. So what about cube roots? Well, remember, cube roots are 3 identical factors, and knowing your perfect cubes is a little bit more challenging. 3 times 3 times 3, 4 times 4 times 4, 2 times 2 times 2. So 3 times 3 times 3 is 27. So it's going to end up on this side. 2 times 2 times 2 is 8. So it's going to end up on this side. So you can see that 8 is in between 23 and 20, or 23 is in between 8 and 7, which means the cube root of 8 is less than the cube root of 23, which is less than the cube root of 27. So it means that the cube root of 23 is in between 2 and 3. And again, you can look at, well, what's the difference between 8 and 27? Well, it's 19. And what's the difference between 8 and 23? Well, it is 15. So 15 out of 19 of the way to 27. So again, this is where you use your calculator and go, well, let's just do 15 divided by 19. Or you could do the division on it, 0.79. So you can say, well, cube root of 23 is probably 2.79-ish, right? It is an estimate. It's probably a pretty good estimate. And if we were to check this, we could go the cube root of 23, and we get 2.8. So boom, very close. So that is how you estimate. I'm more interested that you can tell me between which two integers or whole numbers, but the closer you can get, the better. So what about simplifying? So when we simplify an irrational number, it means some of that irrational number can come out of the root. So for a square root, we're looking for factors under my root that are perfect squares that come out, or we're looking for 2 identical factors. So let's just look at 50 2 different ways, okay? The first way is I know that 50 is 5 times 10, which means I know that 50 is 5 times 5 times 2. And I see here I have 2 identical factors, so 2 become 1 on the outside, and I end up with 5 times root 2. So that's one way to do it, and that's a number. 5 times root 2 is a number. It's a lovely number. The other way to look at it is to break root 50, because root, let's say root AB is equal to root A times root B. You can write it like that. So if you know that 50 has a perfect square factor, so in this case 25, you can say that root 50 is equal to root 25 times 2. You're looking for a perfect factor, perfect square. So you would write it like this. And then you would just square root the 25, and sure enough, you end up with the same answer. So you can do it either way. It helps to be able to identify perfect squares, which is why having these numbers kind of in the back of your mind is helpful, because those are your perfect squares. So if you look at 80, it's like, well, is 8 or 10? No. So you could always go like this. You can always break 80 down, okay? 80 is 8 times 10. Well, 8 times 10 is 2 times 4 times 2 times 5. Well, then you get to a point where you're like, okay, I'm looking for perfect squares. Well, 4 is a perfect square, so that means a 2 is coming out. And then I have 2 more 2's, which means another 2 is coming out. And then what's left on the inside? Just the 5. So that simplifies all the way to 4 times root 5, which what that means is if you did know your multiplication a bit more confidently, you could say, well, 16 times 5 is 80, which means root 16 times root 5 is 80, which means 4 times root 5. So in the end, you end up in the same place. As long as every time you can see two identical factors, they can come out of the radical. So look at 300. Well, what's 300? 300 is 3 times 100, which means it's root 3 times root 100. Root 100 we have an answer to, 10. So we end up with 10 root 3. That is how we simplify irrational numbers. Sure, we're not getting perfect values, but they're looking a little bit more simple than they were with everything under the radical. It's the same for cube roots, except again, we're looking for perfect cubes. So you can either say, well, okay, 8's a perfect cube, 27 is a perfect cube, 64 is a perfect cube, and so on and so forth. So if you know those, it helps, because if you look right away at 40, well, that's the same as the cube root of 8 times 5, which is the cube root of 8 times the cube root of 5. And the cube root of 8 is 2, so you end up with 2 times the cube root of 5. Boom. So it's helpful to identify perfect cubes. If you can't do that, let's look at 54 a different way. I'm just going to break 54 down. 54 is 9 times 6, which is 3 times 3, which is 2 times 3. So that means the cube root of 54 is the cube root of 2 times 3 times 3 times 3. And since it's the cube root, I'm looking for 3 identical factors. Here they are. 3 become 1 on the outside. I end up with 3 cube root 2. Simplified my cube root. 4th root is the same, except what am I looking for? I'm looking for 4 identical factors. So in this case, let's break 48 down. Well, 48 is 4 times 12, which is 2 times 6, which is 2 times 3, and 4 is 2 times 2. So it means the 4th root of 48 is the same as the 4th root of 2 times 2 times 2 times 2 times 3. Well, in this case, 4 become 1. So 4 2's come out as 1 2, and I'm left with the 4th root of 3. That is how you simplify roots. You're looking for what can break out of the house, what can come out of the root. Entire radicals are where we work backwards, so we're going back in. So it's important to identify the index of the root. So I have a square root, I have a cube root, I have a 4th root. That's important to identify, because you got to think, if it came out, it means there were that many of them on the inside. So if you have 3 root 5, it means you must have had 3 times 3 times 5 on the inside, because those 2 3's came out to give you that. So when they go back in, 9 times 5, you get back to root 45. For a cube root, if a 4 came out, it means you must have had 3 of them on the inside, which means you had cube root of 4 times 4 times 4, which is, 64. We could also go 4 times 2, which is 8 times 16, but either way, 64 times 2, you end up with 128, because those 3 4's came out to give you that 4. And for a fourth root, if a 2 is on the outside, it means you had 4 of them on the inside. So it means you had 2 times 2 is 4, 8, 16. 16 times 3 is 30 plus 18, 48. So you had the fourth root of 48. So you're putting things back into the radical. So that's it. Simplifying or going back in. It's all about perfect squares, perfect cubes, perfect fourth powers, fifth powers. Can you get identical factors underneath? And when you do, they can come out. Or can you put them back in? All right. That is it. I'll put a couple short videos out for this, but this topic tends to go pretty smooth. So we're going to move into our next section after this, which is going to get into graphing. So just make sure for this section you have narrowed down exponent laws, radicals, and how exponents and radicals are related, because you will see them again in grade 11, grade 12, and on to calculus if you go there, and it's all about getting more and more comfortable with it. So I hope you enjoyed this one and it helped out. Thanks.